Hi, everyone. Thank you for joining us for today's BigML partner webinar, Machine Learning Fights Financial Crime, featuring Inform Software, headquartered in Germany. My name is Atakan Cetinsoy. I'm the VP of Predictive Applications at BigML, and I will be moderating the webinar. Today's presentation and demo will be given by consultant and data scientist at Inform, Dr. Kevin Nagel. Kevin holds a PhD in biological sciences from University of Cambridge, and he has over a decade of multidisciplinary analytical industry experience, spanning bioinformatics, agriculture, and financial services. As for our agenda, I will kick off with a brief refresher on BigML and some general information about the card fraud problem. Kevin will then take over and briefly introduce us, Inform, the company, the hybrid AI concept that they have developed, and give us a tour of Inform's RiskShield ML product offering. Finally, we have reserved some time at the end for live Q&A, and please be sure to stick around for that because we need you to ask some great questions. Chances are many of you are already familiar with BigML, but in case we have some new users in the audience, I'd like to tell you a little bit about our company. Founded in 2011 with the mission to make machine learning easy and beautiful for everyone, BigML has developed a comprehensive machine learning software platform that now supports over 130,000 users worldwide on its multi-tenant offering, along with dozens of innovative enterprises and partners implementing predictive use cases on their private deployment versions of BigML. Our vision at BigML is that machine learning will ultimately be part of every software application. So it's no surprise that the current set of predictive use cases solved on our platform span many industries that are growing in numbers by the day. For instance, closer to today's topic, BigML's finance and banking customers represent a sizable chunk of activity with use cases such as loan risk and default analysis, know your customer, anti-money laundering, remediation optimization, equity price prediction, in addition to today's topic, fraud detection. If we are to zoom in on the global problem of card fraud, we see in the 2019 Nielsen report that global card activity came in around $41 trillion in 2018. It's a huge sum indeed. Against that large figure, the industry experienced approximately $28 billion in card fraud. This represented 6.86 cents of fraudulent transactions per $100 of spend, despite best efforts to prevent them. The all-time high of 7.2 cents per $100 of spend was reached back in 2016, according to this data, and the figure has been gradually coming down since then. Nielsen projected the continuation of this trend in the 2020s to sub 6 cent levels with the use of better technology, as we will find more about today. Of course, we must add that there will likely be a new twist and a new set of challenges companies need to adapt to in the post-COVID era as new consumer spending habits take shape. So what makes the card fraud problem such a hard business problem to solve? Well, we can mention several factors. The first one being that it's a highly data-intensive problem involving billions of consumers and transactions, millions of merchants and products or services, generating an enormous data exhaust with hidden patterns. Second, the attack vectors of card fraud are not static. Quite the contrary, they are very much adversarial, as the fraudsters are constantly changing their methods, both online and offline tricks added to their bags, such as phishing and social engineering. To make matters worse, those bad actors have recently been leaning on more technologically advanced tools to further their exploits. Finally, for the foreseeable future, businesses have to keep firefighting against this global business problem in a scalable manner by adopting new technologies and customizing those to fit their local patterns of consumption and regulations with the help of vendors like Inform. This completes my intro. Before I turn it over to Kevin for the main event, a few quick reminders. You can enter your questions in the questions area on your GoToWebinar client during the session. We will answer those and publish them as we go. Alternatively, you can participate in the live Q&A at the end of the presentation and demo, as I mentioned before. If you're taking notes, please keep in mind that we will also send you the video of today's presentation and a link to the slides later this week. Without further ado, I'd like to introduce Kevin, and he will introduce to us, inform the company, tell us what hybrid AI is and how it can help companies prevent card fraud.
Thanks a lot for the intro. Well done, and thanks a million for the opportunity. I'm quite excited. I'm more than excited. I guess you can also tell by my trembling my voice. So I'll try to fit in shoes and then give you a good overview of our solution, our RiskShield ML product, and I'm looking forward to your questions, and I hope to give good answers to them. So, so I have the duty to present or give you an introduction to our company, but I have also the luxury to do it in my way. So, having said that, that means what? So, as Atakan said, I have a scientific background, and go back few years. Imagine me, Kevin, working as a scientist in the industry. I already have experiences in text mining, bioinformatics, data analysis, computer vision, and then I was looking for a new challenge. I scouted around and found Inform. And why was Inform so interesting for me? Well, it's a spin-off from the university. It has a tradition in operation research. And so they have many co-workers working for the company, up to 1,000, I would say. And they have a diverse set of applications, such as aviation, logistics, as well as risk and fraud. And that is why this caught my attention and interest, and I applied for a job and got the chance and the luck also to work for them, and in particular in combination with machine learning. And as you see here in this slide, this is now the intro to the department that I'm working for, risk and fraud department at Inform. There are several applications that we are working on, such as payments using the credit cards, or merchants, finding out how to protect them, assessing risks of transactional data, as well as in insurance. AML stands for Anti-Money Laundering, Compliance, and Telecommunication. I was lucky within my few years at Inform that I could dive into several of these topics. And I'm looking forward to even more projects such as AML compliance. So I hope this was a fresh way to present the company. If you have any questions, drop me a line, then I'd like to tell you a little bit more about that. Well, let's talk about banking and machine learning, shall we? So let me ask you, do you know how the credit card payments system works? I guess you do, but here's how I explain it. So here at the top, this is me, Kevin, and at the side is Molly, my bike. So Molly and I, we've done many tours this summer here, even with COVID, but that was no problem, and it was great. And as now the days are getting shorter, we both realized that we need more lights, more protections, in fact, to have a safe trip. So what did we do? We went online. So I found a shop in the internet. I found some cool lights and want to purchase them. And this is the story of the little story of how my credit card went around the world, so to speak. So it starts with that I found the item that I want to buy. I put it into a basket of the merchant online, and I want to go on for purchasing them. The purchase request or the payment request is then from the merchant is forwarded to its acquiring bank provider, to the acquiring bank itself. The bank then forwards the details to the card scheme and requests for authorization. Once the issuing, my issuer bank, approves this transaction, the money is then transferred and deposited to the merchant's account, and the merchant is notified that the transaction had been successful. The goods is released, sent back to me, and everyone is happy. So as you can see, this cycle of how transaction works involves multiple players in this game. And we take part in several areas as symbolized by these shields here. We take part and make our contribution. How do we do that? Well, we analyze the data that has been used in the transaction. We monitor the data. We keep profiles of these data. Data such as, well, which IP address was it used for this transaction? How were the mouse clicks? Is it me or is it actually someone else? So keeping a profile of the username, as well as about the money spent. What's the movement of mine account? Is it usual that I always spend hundreds of euros, let's say, on a Sunday or not? So all that, this is what this is our specialty, if you want, Inform specialty, to process a lot of data, transactional data, and monitor them. Our product is RiskShield. RiskShield is a suite of multiple software components. One of the components is the server, which operates 24/7, which is obviously necessary in this sector, in this business sector. As a 24/7 server, it can process requests more than 5,000 transactions per second. These transactions are then assessed, the risk analyzed by using sets of rules specific to the application domain, as well as incorporating your business logics. So for that, we have a component, it's called the rule editor, but as well as a lightweight versions available within the application center. As a result, we receive the requests, as I said, we process them in a fast manner, and we process them in a high volume as well. So responses of transactions, more than hundreds of millions of transactions per day, for example. We can also generate alerts. So the fraud expert can then see those alerts and then mark them as, yes, these are correct alerts, and then please decline the transactions or do the opposite. What I like to do now is I like to pick two applications that we have from the application center. So just to give you a glimpse of what our software looks like. So I'm switching to this tool here. As you see, the name is called RiskShield Rule Management. The idea of the rule management is to have simple rules written down by fraud experts and to operate with them. It's not the only way to write rules, business rules, but it's just a lightweight version, let's say. So as you see, there's in this demo here, I have 5 rules listed on the left-hand side. Let's pick, let's say, the high MAC stripe ATM rule. You see there's a condition block and there's also the action block. Condition block is where the fraud expert can say, well, up to a certain amount, and then depending whether the merchant category code is at ATM, I want to decline the transaction. I also want to create a case if necessary. If you want to change the rule, it's possible and it's easily done. You go to edit, you can say, well, merchant category code is at ATM, but there's also drop down and you can say, well, it's also airlines. There's also some other businesses I want to keep track and so on and so forth. Typewriter stores, truck trailer rental, whatever it is. So what I want to convey you here is basically that rules, simple rules, can be built in this manner, as well as you have the options to say what the actions are: decline the transaction, accept the transactions, or generate alerts for the fraud expert to analyze. Okay, so that is in a nutshell what this tool can do for you. Let me just cancel this quickly. Now, as I said, we can generate alerts for the fraud expert. And how can we see those alerts? Well, there's another tool. This tool is called case management. Let me jump to it real quick. So this is an overview of alerts that have been stored and made available for the fraud expert. Let's say we would pick one of these alerts, and it will open another view of the data. Just takes a few seconds. Okay, here we go. On the left-hand side, you can see different types of data you can look at. So the case that had been created, the card data, so you can see some of the master data as well, transaction history, so past transaction that have been done with this specific card, and you can apply actions such as, well, this alerted transaction looks a little bit fishy. I want to block it, for example, or you want to block and replace it. You can also see the details why it was actually alerted. You can also have a score that we calculate to assess the data. We call it RiskShield score, and so on and so forth. And if you jump back quickly to the slide, this is a glimpse in a nutshell, or more a glimpse of our product, RiskShield. RiskShield with multiple components, incoming multiple requests, process them in a fast way, and also in a high volume. Now, the product itself is not only suitable for the banking sector. As I said, we also have applications in the insurance sector, as well as in telecommunication. And if you think about it and remember what Atakan said, the challenge here is that we have multi-dimensional data, digital data that is growing every now and then. More methods are available, for example, to make payments. Think of Apple Pay, Google Pay, wallet, with all the wallets. So what we're talking about is we need a way to deal with the data, and we're talking about digital decision making, and that is the core of Inform, digital decision making, applied for in the banking sector for risk and fraud assessment, as well as for logistics and aviation and so on and so forth. So for that reason, and to deal with that, we have forged a second shield, a second product we call RiskShield ML. RiskShield ML inherits all the goodies from RiskShield. As you can see here on the left-hand side, the major component I like to stress out here is that we have a module for auto feature engineering. I'm going to talk about that a few minutes. And as well as the prediction, that is using the model that is built by the machine learning environment and put it online, and then again in a high volume, in a fast way. RiskShield ML also has all the goodies from BigML, our partner. So such as data sets management, all the algorithms available for supervised learning and unsupervised learning. This is a path how machine learning is done, or the data scientists sort of stick to it. I'm certain you're familiar with it, but let's go over it just real quick. It always starts with stating the problem. Depending what your business requirements is, this could take a few hours to really formulate it. But let's say our goal is to fight crime. So that means predict fraud. And since we have the data analysts, we can have also labels at the same time. So then we are talking about supervised learning. supervised learning, where we have data and we know the target, the fraud marks. What follows is it always starts with having data. We need data. Having data, reference data, we need to massage the data in a way that it represents something meaningful. We also need to transform the data in a way that we can link and associate with external data, for example, for enrichment purposes. What comes at the last step of data manipulation is that a field called feature engineering. If you ask now, what is feature engineering? What is it different from data wrangling and data transformation? Well, think of it like this. You have data, you have information, then you come to knowledge, and at final to wisdom. And it's the same hierarchical point of view. The point of feature engineering is not just to change a little bit the data itself, but actually extract information, meaning from the data, something that is not easily accessible in the raw data itself. So feature engineering can provide you and enrich the data with informative stuff. Once we have that, we go into the modeling. Models are built on the basis of the data. Patterns are searched using different sets of supervised algorithms, and models are evaluated. Once those models are evaluated and then checked that they are well performing, we can apply those models. So we come to predictions and then measure the impact. All of those components are important, okay? Really important. So it's not just data wrangling, it's the top priority of feature engineering. All of them are important. They work in concert. But somehow I gravitate towards feature engineering, and I'd like to show you the following slide here to hopefully it makes sense and can highlight the point why feature engineering is important. So please bear with me. What you see in front of you is not a hacked screen of yours. No, this is still my slide here. You see, hopefully you can see it if you are real close in front of your screen. Some digits like there's an 8, there's an S, so characters, and then at sign, and so on and so forth. Give it that to a machine, to the computer. You can ask the machine to learn some patterns, figure it out whether there's something special to it, and the machine might figure it out, yes, there's an idle with all the 8s and stuff like that. So you can think of it that this is like a data stream that you receive, and you're simply giving it to the machine to learn some patterns and then make some prediction, find out whether there's anomaly or any classes of data. What the machine, though, cannot do easily is to know the semantics. What is the meaning behind it? Why do I have these kind of patterns? So there are two ways now for you to understand what I'm trying to explain it. Either you step back 2 meters away from your screen, okay, or I would simply zoom out a little bit and hope now step by step you can see it. Can you see it? So what you should see is the following. There's a hooded guy, this is the head, with the arm extending in front of his computer, and there's the screen of his laptop. Basically, it's an image of a person committing crime. So it's a complete different semantic. If you tell this to the machine, then the machine knows, aha, there's something special encoded in this. And yes, this is sort of a metaphor or an allegory, or a bit philosophical, but at the heart, it's very true. The machine has no concept of semantics or information. It's simply data. Let me jump back to the correct screen view. And so the machine needs to learn real tiny bits of information and work with those information. One way of doing that is what we almost hear every day in the daily news, is to use a hip algorithm called deep learning. Deep learning, as you see at the top, basically does what? On the basis of a few sets of input data, attributes, variables, it sort of figured it out itself what it can derive from it. And these are called neural networks with multiple hidden layers. They are basically weights of the input and then combine in order to get another combination of intermediate variables. So it's basically deriving some information on the basis of few inputs. It works. It has shown to work. It takes time to learn this kind of model. And it's also hard to maintain because, well, it's pretty much like a black box. And so within the area, at least in the banking sector, what I understand is it's a no-go. You can't apply this model and then tell, hey, that's why I rejected your transaction because the machine told me so. So it's a black box. It's not really satisfying. The alternative, though, is to move this part here that I'm highlighting with the multiple hidden layers here to the front. So that is the discipline of feature engineering or the auto feature engineering. What does it mean? It means that coming from using a few sets of input variables, the human expert can say what information are encoded within, such as is it a weekend transaction? What is the delta on the time difference between now and the last transaction? Is it a high amount transaction that we have? So you're applying almost like a business information to it, business logics. Depending on the category of payment, you can say this is a card not present or card present transaction, and so on and so forth. But you can also do something more to it, more automated things, such as you analyze what is the minimum value that you observe, amount of transaction, for example, per month or per day, or the actual amount that you spend, the cumulative amount that you spend, or what is the average minimum amount that you spend per day. So all these things is related to feature engineering, and the goal is to get a rich set of features, descriptive features, but also in an automated way. Once you have that, you can build very robust and powerful models such as decision tree or sets of decision tree, also known as random forests. The way how we do this is using an algorithm or approach called split, apply, combine. So let me guide you through this one here. Remember when I said that we are good at in analyzing data and also in monitoring data. So we're collecting data here. And in this here, what you see on the left-hand side is the calendar of October. So this is Monday, Tuesday, Wednesday, and so on and so forth, with the calendar weeks 40, 41, and so on and so forth. And then we are now here, 28. So let's say today I'm spending some money, and the machine has to tell whether this is awkward, strange that I'm spending so much money now, or whether it's completely normal. How can it do that? Well, it has to put it into context, compare, having a reference. What is a reference? Well, as I said, we're collecting data. The data is available in our system, in RiskShield. So we can describe the context. How? Well, we could split the data in depending on time sections, ranges. We can apply simple primitive operations, such as determining what is the mean, what is the maximum, what is the deviation, what is the count, what is the sum, and so on and so forth. These features that I just told you can be already used and fast forwarded to the machine learning. But what we can also do is to do the third step, that is combine it. So that means that I can determine, let's say, the average spend 3 weeks ago in comparison to what was done in 2 weeks ago. So it's a different way to put things into context and analyze them. What I'd like to show you quickly is another tool that we have. It's mainly for rule writing on an expert level, but now tuned in a way for this split, apply, combine, and that is for auto feature engineering. So let me jump to this tool. This is the tool called RiskShield Client. Hope you can see that at the top in these columns, you have the split sections, the apply sections, and the combine section. Similarly as what I've shown you in a previous slide. What I'd like to do is to go into the applied module. What I want to tell you that at the top here, there are different, as I said, ranges of time. So these are slices of the monitored or profiled data that we collect. And we can generate different application rules. This one here basically, as you see, has actions, and built in our software have been already these functions in, let's say, count the amount of records. So how many transactions have I done? Store the minimum amount, for example, that I have done within the last 3 weeks, for example. And or there are even more features that we can compute in our software by default. Okay, so the user of our tool really benefits from a rich set of features that we can compute with this tool. Okay, I'm going back to the slide. Moving on. Okay, we understand auto feature engineering means enriching the raw data set for the benefit of extracting information that we hope that is descriptive and helpful to build a powerful model. So therefore, we have the data, and the next step would be building a model. Once we have the model, we apply it. Is that the end of the story? Well, it's not actually. In fact, we have something called MLOps, machine learning operations. It's similarly like DevOps or DataOps, and in fact, the community, the data science community, have acknowledged this concept of MLOps already quite some time now. The idea is what? The idea is that, well, think of it, the world is changing. The world is changing fast and sometimes in a way that you're not expecting. So that means you don't want to simply build a model because you can build a model and put it into operations, but you have to maintain the model as well. You have to update the model. You need to have, you know, options, ways, strategies to evolve the model as well. So in this MLOps cycle here, basically in an operation, in a production system, we can extract data, archive, create subsets, training data sets, the test set, build a model, learn the model, evaluate the performance of the model, and release it back to the production system. And that is another view or explanation of what RiskShield ML is. RiskShield ML inherits, as I said, all the goodies from RiskShield, which is putting things into operations in a fast way, in a robust and stable way, 24/7 server, for example, but also combined with the power of BigML with learning models and evaluating the models. And we have the features and capability as well as the power to maintain this cycle here. What it means on the left-hand side, the machine learning part, is perhaps I can show you real quick in this demo as well. This is our RiskShield ML platform powered by BigML, as you know it. If I go real quick to the dashboard, I have a project here I need to connect. Here we go. What do we see here? As I said, we have several cycles. You can think of it that I have monthly subsets of data that I have extracted and then uploaded to this platform here. So you see there's 2019, the third, there's a segment of data that I've uploaded, and for the subsequent month as well. For all those uploads, I can create data sets. I can create a data set and define what is my test set and also the corresponding training set. For the training sets for each month, I can then build models. This one here would be a random forest, for example. And I can decide whether the model that I've built is the champion. So using the idea of champion challenger. What is champion challenger? Well, I can have a model. I can create a new model and compare if that new model, the challenger, is outperforming the previous model. If that is the case, then I have a new champion. The old champion, I call it simply as former champion. If it's not outperforming, then the challenger becomes second place, or what earns only the second place, so to speak. So this is the idea of ML ops, and you see how it's lived in this tool here. Right, going back to the slide. At the end of the day, what's the benefit? Well, if you think of it that, again, we have RiskShield and RiskShield ML, all combined is what we call hybrid AI. Hybrid AI in a sense of we combine all the knowledge base goodies, rule writing, as well as all the power of machine learning, finding patterns and utilize the identified pattern, the model, to make predictions. Both of them can produce a score that we can observe, analyze, and utilize in case management. So this is a screenshot here showing you, again, the case management tool. You can see the RiskShield score as was shown to you before, but now we also have available the RiskShield ML score coming from RiskShield ML itself. And so the interesting part is now to combine both of them in this hybrid AI approach of risk and fraud assessment. I'd like to make a quick summary. Just looking at my watch, I think it might be a bit fast, but nevertheless, here we go. What did we learn today? Well, I showed you RiskShield ML. RiskShield ML is essentially an auto feature engineering tool combined with an evolving machine learning part. It is the solution to make transition from lab to production. Meaning what? Meaning, well, there are a lot of machine learning environments. We can always download some CSV file and then build a model, but how do we put it into production? Again, in a performant way. RiskShield ML is the answer. And RiskShield ML in this context fits in tightly and nicely to our core goal, which is digital decision making. With that, I'd like to thank you for your attention. It was a pleasure to give you an introduction into RiskShield ML. If you'd like to want to know more about the software or about the company, or simply want to get in contact with me, please do not hesitate to write me an email at riskshield@inform-software.com. Thank you.